Okay, Algebra 1, Lesson 67. We're going to talk about solving and classifying special systems of linear equations. This is something that you do want to get down, that you want to take good notes over, because we hit this really heavy over and over and over again in geometry and Algebra 2. Okay, so I know that you have to take more math classes than just this, right? You have to have 3 high school math credits. This is 1 down, 2 more to go. So if you get some of this down, I'm just telling you it's going to help you out in the future. So systems of linear equations can be described by their common solutions. When we're talking about systems of linear equations, what we're talking about is looking at a graph or a set of equations where we're working with more than one linear equation. And when we say a system of linear equations, or what is the solution to a system of linear equations, we're talking about where do those two lines cross, or where do I have an x and y value that will solve both equations? Does that make sense? Okay. So if there is no common solution, the system is described as an inconsistent system or inconsistent equations. What that looks like as a picture is when we have two parallel lines. Do two parallel lines ever cross? Therefore, they never have a common point. There's no x and y value that they share that will solve both systems. Does this make sense? Now, if I were to solve both of those equations and put them into slope-intercept form, we would find something to be true. We would find that two parallel lines have the same slope. So these equations are going to have the same slope, but they will have different y-intercepts. That's what's going to keep them parallel without ever touching. Okay, so far can we kind of get some of that visualized in our head? So we see what the equations would look like, and we see what the graphs would look like in an inconsistent system. The graphs of inconsistent equations, they never intersect. Therefore, since parallel lines never intersect, the graphs of inconsistent equations are the graphs of parallel lines. So notice that we have that word in bold, inconsistent equations. Inconsistent equations are, and you should be able to say, parallel. Okay, parallel lines are inconsistent equations. Other systems of equations, known as dependent systems, have an infinite number of solutions. What would that look like? If two lines have an infinite number of common points or common solutions, what does that look like on a graph? They're the same line. They overlap each other, which means at every single point, they're the same. Okay? So that's what we call dependent systems. The equations of dependent systems are called dependent equations, and they have identical solution sets. If we solve them for their y-intercept form, we would find that they have the same slope and the same y-intercept. Okay, so no matter what I plug in for x and y, it's going to solve both equations the same way. Okay? Since they have identical solution sets, the equations are the same equation whenever they're simplified. Two methods can be used to solve dependent systems algebraically. One method shows that the equations are identical. The other method shows that the variables in dependent systems can be assigned any value. So both equations have infinite many solutions and infinite set of ordered pairs. Okay? And then we have something called a consistent system. So let's go back and let's talk about what we've learned already. We have what was first. What kind of system was first? The inconsistent system. What did that look like? Two parallel lines. Do they have any common solutions? No. So no solutions. Okay, what was next? Dependent systems, right? What did those look like? Infinite solutions, overlapping lines. And then we have something called a consistent system. Okay? And this is maybe the most common set. They will have at least one common solution. Okay? Now notice it uses the word at least. So something can be both consistent and dependent, because we're either going to have one solution or we can have infinite solutions. So two overlapping lines are considered both consistent and dependent. Okay? An independent system will have exactly one solution. So that's where it's a little separate, okay? An independent system is also a consistent system. So independent and dependent systems are both considered consistent. Do you follow me? All right. An independent system is also a consistent system. The graphs of the equations of an independent system will intersect only at one point. Systems of linear equations can be classified into three different categories based upon their number of solutions, and that's what you're going to see here. Okay? We have consistent and independent, where there's exactly one solution. We have consistent and dependent, where they overlap, so there's infinite many solutions. And inconsistent is totally over here by itself. Okay? It's just inconsistent. There is no solution. So we see we have three categories. Two of those categories include consistent. Okay? Third category is inconsistent. So if you can kind of get this graph down and this chart down and understand it, you'll end up seeing this chart several times next year in different lessons, in different chapters, and different scenarios, but effectively you're going to see this chart over and over again. Okay? And you can get a little description down here at the bottom. Okay? I don't have some little catchy mnemonic way of memorizing this. It's just sitting down with the chart and trying to get it into your head. Okay? Not everything, there's not an easy way for just everything. That's it on that side of things. Let's see if I can find, here we go. All right, so question number 1 here, we want to solve the system of equations for x and y. And we have multiple ways of doing this, right? We've learned about substitution. Substitution, we solve for a variable and then plug in, correct? We've also learned about elimination. What does elimination allow us to do? You can add them and then eliminate a variable, correct? Okay. Was that easier to do here than substitution? Yeah, because I have a positive x and a negative x. So if I add the two equations, what happens to my x's? They cancel out. Okay, what do I do next? I have 4y and y. What is that? 5y. Now what? What is negative 19 plus negative 1? Negative 20. Very good. Okay. All right, now what do I do? Somebody else. Jordan? Divide by 5 on both sides. So y equals what? Negative 4. Okay, well that eliminates. Now notice that this is the y equals. So if I'm putting it over here in a coordinate notation, which side does it go on, the left or the right of the comma? The right. Okay, so I put that there. That eliminates D as an option, eliminates C as an option. Okay, it doesn't necessarily eliminate E. Now that I know that y equals negative 4, what should I do? Plug it in for what? Y. Okay, so as I erase this to kind of make some space, which equation would you plug in negative 4 for? What, the top one or the bottom one? You do it into the top one. Okay, that's fine. We're going to get x plus 4 times negative 4 equals negative 19. We could have done the bottom one, right? Could we have done negative x plus negative 4 equals negative 1? Yeah, would be fine. Okay, what do I do here? Somebody besides Mia, she's kind of carrying the class right now. 4 times negative 4, I'm told is what? Negative 16. Okay, somebody besides Tiffany, she's doing her fair share. Somebody else? What do you think, Caden? Add 16 to both sides. That's going to cause my 16s to cancel out. All right, I'm going to get x equals what? Negative 3. Okay, so we get negative 3, negative 4. And I could go ahead and if I plugged both of those in, okay, let's see, we would have negative 3 plus 4 times negative 4 should equal negative 19. And notice here, this would be negative 3 plus negative 4. Does that equal negative 1? Well, what happens with the double negatives? So I'm getting 3 plus negative 4. Is 3 plus negative 4 equal to negative 1? Yeah. Okay. So negative 3, negative 4 is a solution to both equations. Okay. Is there an infinite number of solutions here? No. Okay. So what kind of system is this? It's consistent and independent. Okay. So we're going to work on, after we've solved a system like this, is going ahead and establishing what it is, because the more that we practice with it, hopefully the better that we get with it. Okay? Let's look at number 2. We have negative 2x plus 2y equals 2. We have 2y equals 2x plus 2. I'm going to try something different here. Can we change both these equations to y-intercept form? Yeah, let's try that. What would I do here with this first equation? What's the first thing that you'd do? Okay, add 2x to both sides. That's going to give me 2y equals 2x plus 2, correct? Now what would you do? Divide by 2 on both sides. So that's going to give you y equals what? X plus 1, okay? All right, let's look at this other one. What would I do here? Divide by 2 on both sides. So that's going to give me y equals what? X plus 1. Right? What do we notice about those two equations? They have the same slope. They have the same y-intercept. They are the same equation. How many solutions are they going to have? An infinite number of solutions. Okay? Now, let's see what that looks like in a different scenario, right? We can see if they're the same equation, then they're going to be the same line. I'm going to get infinite solutions. The other thing I could do is, let's say we divided this by 2 again. That would give us y equals x plus 1, right? So I could come back up here and plug in y, or I could plug in x plus 1 for y. That would give me negative 2x plus 2 times x plus 1 equals 2. So that's giving me negative 2x plus 2x plus 2 equals 2, right? Well, I've got negative 2x plus 2x. What does that come down to? Right? Well, actually, it's 0. It cancels out. And what would I do here? I would subtract 2, right? Okay. Well, what's 2 minus 2? 0. So I get 0 equals 0. Is this a true statement? Yeah. Therefore, it's infinite many solutions because I've eliminated all my variables, and I have a true statement. Now, if I got something like 0 equals 5, is that a true statement? Right, and if I get something like this where I have no variable equal to, I get 0 equal to something that it's not equal to, then what we would say is no solution. Does that make sense? What that means is that these two lines are parallel. There's no solution. All right, do we understand some of the concepts that we're working with here? Okay, let's look in your book for a second, because I don't want to make sure we kind of answer a question or two that you're going to need. What do you think? Anything in there? $22? Okay, 22. Okay, so it says y equals x minus 5 and y equals negative 2x plus 1. Let me get that up here. Y equals x minus 5. Y equals negative 2x plus 1. Okay, Christian. We want to solve for this system. What do you want to do? They're both set to y equals. Could you use substitution? How would we use substitution here? Multiply what by 2? You don't know? Does anybody know how to use substitution here? Right, we could take this negative 2x plus 1 and sub it in for this y right here, correct? Is that what you're saying? So we'd end up writing negative 2x plus 1 is equal to x minus 5. Does this make sense, Christian? All right, can you take it from there? Negative 2x minus x, so you're going to subtract this x, right, from both sides? Is that what we're saying? All right, what's negative 2x minus x? Negative 2x minus 1? You have negative 2, negative 3x. Okay, negative 3x plus 1 equals negative 5, right? Okay, what's next? Subtract 1. Okay, what's negative 5 minus 1? Negative 6. What do you want to do now? Divide by negative 3. Okay, what does x equal? 2. Good. All right, what's next now? Plug what in? In for what? Where? Okay, so you're going to do y equals negative 2 times 2 plus 1, correct? Okay, and solve for what? Solve for y. Okay, tell me how to do that. Negative 2 times 2, what is that? Okay, negative 4 plus 1. What's negative 4 plus 1? Negative 4 plus 1 is negative 5? Negative 3. Okay, so if I'm writing this as a coordinate notation, how do I write that in? What goes on the left? Negative 3 goes on the left here, you think? 2. Okay, and on the right, negative 3, because x is on the left, y is on the right. So I get 2, negative 3 as my answer. Okay, I think at this point, hopefully we feel pretty good about this. Yes, kind of? All right. And remember, you do have another video that you can look at.